Okay, here we have the 6-6 additional practice, conditions of special parallelograms from the Savvas geometry. So this goes with our 6566 assignments for practice problems. So let's look at these. Now, if you want full credit, you need to do all the evens on this. So let me circle those. We got 2, 4, 6. So we got down here. And 8. I think that's all of these things. You got to do 2, 4, 6, and 8. And we will, in this video, we'll do like say 3. And we'll talk about 4. And I'll do 5. And we'll talk about 8. And let's talk about 7. Okay, so let's see what we got. Okay, so let's look at number 3. Which word best describes each? Okay, let's see what we got. So here, the diagonals bisect each other, but they're not congruent. They're showing us that these diagonals have different lengths. It's a parallelogram. So we have a parallelogram that has diagonals of different lengths. That's got to be just a general parallelogram. If it was a rectangle, the diagonals would be congruent. And if it was a rhombus, the diagonals would be perpendicular bisectors of each other. Set up number 4 here, we have a parallelogram. It's shown that the diagonal bisects one set of angles. So it's not going to be a rectangle because rectangles don't have diagonals that bisect. Parallelogram. They're not telling us that all the sides are congruent. This, I believe, is going to be just another parallelogram because, I don't know, is it? These diagonals don't bisect, so diagonals bisect. They don't bisect in a rectangle. They do bisect in a square, and they do bisect in a rhombus. So I guess this would have to be a rhombus. Okay, let's look at number 5. What value makes this true? Okay, so it's supposed to be a rectangle. AC and BD are given to us. If this is a rectangle, the diagonals need to be congruent. So that means 4x minus 5 would have to be equal to 3x minus 1. And we can find the x that makes it so. Take away 3x and add 5. Take away 3x, we get x. Add 5, we get 4. So x is equal to 4, which means we get 16 take away 5, which is 9. So each one of these is 9. Is that right? 12 take away 1 is 11, and 16 take away 5 is 11. Each one of these is 11. So if x is 4, the diagonals are congruent. Diagonals have a length of 11. So that's what's going to work for this one. For 6, you want to make it a rhombus. So in a rhombus, the diagonals bisect. So these two need to be equal to each other. And you need to find the x that makes it work out. Let's talk about number 7. What characteristics do the diagonals of a rhombus and of a square have in common? How do they differ? Let's sketch a rhombus. And let's sketch a square and look at their diagonals. So remember, a square actually is a rhombus, just has right angles. So let's see, what do they have in common? Well, the diagonals are going to be perpendicular bisectors of each other. perpendicular bisectors of each. The diagonals are going to bisect the vertices. Bisect vertex angles, rather. There's two things we can see with the diagonals. Let's see. The diagonals are, okay, here we go. The diagonals in a rhombus don't have to be the same length, but they do bisect. But in a square, since a square is also a rectangle, the diagonals are congruent. So in a rectangle, the diagonals are congruent. In a rhombus, this is really what they both have, a rhombus and rectangle both have perpendicular bisectors of each, and the diagonals bisect the vertex angles. But in a rectangle, these diagonals are congruent. Or in a square, these diagonals are congruent. So it goes with the square. What else? That's really it that I can see. Okay, let's set up number 8. Will this tray fit in the box as shown? Let's see what we got to do there. 15.5 inch or 17-inch rectangular tray. And they're giving us the diagonal measurements. So let's see what we have in one of the sides. So let's see. It's a parallelogram. 12, 12, 12, 12. They're showing us that this is a square because this is a 12, this is a 12, this is a 12, this is a 12. So totally the diagonals are congruent to each other. So it's a rectangle. So it's actually, because they're congruent, it's a rectangle. Do we know? Okay, 6. Okay, we don't know for sure without doing a little bit more work that it's actually a rhombus, because now if it's a rhombus, there'd have to be a right angle there. So we can check that. If we check to see if this is a right triangle, we have a 12 and a 12 and a 16. So we could ask ourselves, is 12 squared plus 12 squared equal to 16 squared? And I really doubt if it is. 12 squared is 144. The other 12 squared is 144. 16 squared is 256. And 144 and 144 is 288. So 288 is not equal to 256. So since a squared and b squared is not equal to c squared, this is not a right triangle, which means these are not right angles, which means this is not a rhombus, which means this is just merely a rectangle with one side of 16. We can figure out since these are all 12s though, it's not a right angle. So we know this is going to be a 16. Tell us that this is 16, this is 12. So we got 16 across this way. I don't see any way that a 17-inch is going to fit into this. Check it out See what you think. Explain. Come up with a good reason if you want the points for this.